Good day, everybody. How are you all? This is Dr. Nandi. Today I'm back again to talk about a AP problem in stats. Before I get started, I would like to let you know that my channel has got all kinds of solved problems in math, starting from stats, calculus, algebra, trigonometry, AP stats, then GRE, quant prep. So why are you hesitating? Please subscribe to my channel by hitting the red subscribe button at the bottom right corner of the screen. So without further ado, I'll get started. A manager wants to estimate the average amount of time her employees spend on the phone with clients. She takes a random sample of 20 employees and finds they spent an average of 3.6 hours on the phone with a standard deviation of 0.75 hours. Assuming that time spent on the company calls is normally distributed, which of the following equations can be used to estimate a 95% confidence interval of the mean phone time? And there are 5 alternatives. So, first we have to realize that the sample size is 20, which is less than 30. So we have to use a t interval. We cannot use a z interval because the sample size is less than 30 and we do not know the population standard deviation. However, we know the sample standard deviation. Now, degrees of freedom, when with t interval, we are always constrained by degrees of freedom, which is sample size minus 1. In this case, 20 minus 1 is 19. So I have shown the t distribution in the diagram. And remember, my degrees of freedom is 19. 20 minus 1 is 19. Now we are interested in a 95% confidence interval. So area in the center, which is not shaded under the T curve, that area is 0.95. So area of the two tails is 1 minus 0.95 or 0.05 of the two tails taken together. Now we know this curve is symmetric. The T curve is symmetric. So left half is equal to right half. Since the area of two tails is 0.05, area in each tail is 0.05 divided by 2, which is 0.025. Now, in order to find out the uh, confidence interval for the mean, we need the critical value of the t's. The critical value is the value of t on the horizontal axis, which separates the central area where the population parameter or the population mean will fall from the tail areas where the population mean will not fall. Okay, that's why it's called a critical value and it's on the horizontal axis. So the easy way to find this T critical value is to use a TI-84 calculator. There we press the second button and then the worst button. And then we scroll down to number 4, which is in T. Okay, we have to in T. Okay, we cannot use in Z normal. In norm we cannot use. So number 4 in T. And the first line says area. This means the area in each tail. The area in the left tail is 0.025. I already told you degrees of freedom. DF is sample size minus 1, which is 19. And then we scroll down to PEST, put our cursor there and hit enter. And the answer comes out as in T, 0.025, which is area in the left tail, comma 19 is minus 2.093. So this is the critical value of T, which separates the left tail region where the population mean will not fall from the unshaded area in the center where the population mean will most probably fall. Okay, so that critical value on the horizontal axis is minus 2.093 on the left tail. On the right tail, it will be the same value with a positive. So T critical on the right tail will be 2.093. Hence, the confidence interval formula will be sample mean x bar plus minus T alpha by 2. Remember, alpha is your level of significance, which is 1 minus the confidence interval. Here, the confidence interval is 0.95. So alpha is 0.05 and alpha by 2 is 0.025. And degrees of freedom already I know 19 multiplied by the standard error of the mean, which is in this case sample standard deviation divided by square root of n. So finally we substitute the numbers. The mean is 3.6 plus minus critical value we already found out is 2.093 times the standard error of the mean, which is times 0.75 for the standard deviation divided by square root of 20. Now, if we look at our alternatives, seems like C is the best match. C is the correct match actually. So C is the correct answer. 3.6 plus minus 2.093, which is the critical value of T multiplied by 0.75, which is the standard deviation divided by square root of the sample size 20. So I will stop here today. If you have any question, you can always write me a comment and I'll get back to you as soon as possible. And I will come back next time with another AP stat problem. So I look forward to see you next time. Take care. Have a nice day and please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Thanks. Take care. Have a nice day. See you.